Good morning, everybody. Hello, my dear students. Welcome to my YouTube channel, Khandwal Physics. Today, we are going to discuss about a new topic, new portion of electrostatics, that is electric field intensity due to charged spheres. Okay, it's a very interesting portion. So शुरू से एंड तक प्लीज माई रिक्वेस्ट वीडियो को वॉच करो। बहुत इंटरेस्टिंग पोर्शन है, आपको बहुत अच्छा लगेगा। अगर ये कॉन्सेप्ट क्लियर हो गया तो अपने आप में एक कॉन्फिडेंस डेवलप होगा। जितने भी कॉम्पिटिटिव एग्जामिनेशन है, आपका नीट हो या जेई मेन हो, जेई एडवांस्ड हो, सभी में इसके ऊपर क्वेश्चन आता है। अगर ये कॉन्सेप्ट क्लियर हो गया तो आपका एक कॉन्फिडेंस लेवल बढ़ जाएगा। ओके, तो चलो शुरू करते हैं। इलेक्ट्रिक फील्ड इंटेंसिटी ड्यू टू चार्ज्ड स्फीयर्स। सो स्फीयर दो प्रकार होता है। स्फीयर इज ऑफ टू टाइप्स। यू सी स्फीयर, तो स्फीयर दो टाइप का होता है। नंबर वन, इट इज सॉलिड स्फीयर, सॉलिड स्फीयर। एंड सेकेंड वन, ओके, पहले हम होलो लिखते हैं। चलो इधर होलो लिखते हैं, होलो स्फीयर। एंड सेकेंड टाइप इज योर सॉलिड स्फीयर। स्फीयर दो तरह का, होलो स्फीयर एंड सॉलिड स्फीयर। यू सी, होलो स्फीयर इज अगेन ऑफ टू टाइप्स, कंडक्टिंग और यू कैन से मेटालिक। मेटालिक, क्लियर? एंड सेकेंड वन इज योर नॉन कंडक्टिंग। Clear? तो solid sphere is again of two types, conducting, which can be metallic, conducting or metallic, and second one is your non-conducting. So four types of spheres exist. Okay, so hollow का conducting, non-conducting, solid का भी conducting, non-conducting. So listen carefully. एक काम करते हैं, चलो कोई बात नहीं, इसको इधर लिखते हैं, आपको अच्छा दिखेगा। Solid. So solid again of two types, your conducting and non-conducting. Okay, let me check whether the video is running or not. Okay, it is running, thank you. So sphere is of two types, hollow and solid. Hollow is again divided in two parts depending upon its material. Okay, conducting and non-conducting. Solid is again of two types, conducting or non-conducting. So suppose this is my hollow sphere, completely hollow. Okay, so you can tell it cell, it's a cell. Okay, hollow sphere can be termed as cell. So when charge is given to this body, the charge resides on its surface, because we know in the first class of electrostatics. We have discussed about charge cannot exist without mass. मास के बिना चार्ज एग्जिस्ट नहीं कर सकता. सो इट इज ए सेल, इट इज ए होलोस्फीयर. इसके अंदर कुछ नहीं है, तो इसके अंदर चार्ज रिसाइड नहीं कर सकता. सो एज इट इज ए सेल, इट इज जस्ट ए सरफेस. सो चार्ज रिसाइड्स ऑन द सरफेस. क्लियर? लेट इट्स चार्ज बी Q. Clear to all of you? Come over here. It's although it is non-conducting, again it is a cell. When charge is given, again the charge resides on the surface. Again charge resides on the surface. Clear? Now come to third category. It's a solid but conducting. Solid but conducting. Although it is a solid sphere, you see, it is a solid sphere, still the charge resides on the surface. Charge resides on the surface because it is a conducting material. So like charges repel each other, so charge cannot reside inside but comes to the surface. Okay? Charge again resides on the surface. Surface के ऊपर ही चार्ज रहेगा, अंदर चार्ज नहीं रहेगा. Although there is mass, it is a solid sphere, still the charge will reside on the surface because like charges repel each other. Now come to non-conducting. Okay? So here, as it is non-conducting, suppose charge is given, charge is over here, it will reside at this position. जिधर भी चार्ज देखो, again it is of although two types, but we are going to deal with uniformly distributed solid non-conducting sphere. Uniformly distributed solid non-conducting charged sphere. We are going to deal with uniform distribution of charge over here. It may be non-uniform, but we are going to deal with uniform distribution of charge. Okay. So out of these four types of spheres, you see in these three cases, charge resides on the surface. You see, charge resides on the surface. So that's why it is very interesting now. Now the complicated problem has been made easy. Okay? ये तीन टाइप को हम एक कर देंगे. इसका जो रिजल्ट आएगा, इलेक्ट्रिक फील्ड इंटेंसिटी, वी आर गोइंग टू फाइंड आउट इलेक्ट्रिक फील्ड इंटेंसिटी. इसका जितना आएगा, इसका उतना आएगा, इसका भी उतना आएगा. तो इलेक्ट्रिक फील्ड इंटेंसिटी ड्यू टू ऑल दीज थ्री स्फीयर्स, hollow conducting, hollow non-conducting, solid non-conducting, these three cases are same because charge resides on the surface. Clear to all of you? और ये हमारा होगा स्पेशल कैटेगरी because charge is uniformly distributed throughout the body. ओके? इसको हम बाद में डील करेंगे केस 2 करके. अभी केस 1 में ये तीनों को मिला के हम पढ़ेंगे. ओके? नाउ लेट मी इरेज दिस पोर्शन. Okay, so my case 1. So case 1 में we are going to deal with hollow conducting. First case hollow conducting. Second one hollow non-conducting, and solid conducting. We are going to deal with Simultaneously, we are going to deal with these three cases because these three cases are the same. In these three cases, charge resides on the surface. Okay. So electric field intensity due to these three spheres will be the same. चलो शुरू करते हैं, कैसे निकालते हैं? तो again we are going to number A case outside the surface. Outside the surface. Outside the surface. केस 1 का ये स्पेशल केस है, स्पीयर के आउटसाइड वी आर गोइंग टू फाइंड आउट द इलेक्ट्रिक फील्ड इंटेंसिटी आउटसाइड द सरफेस. चलो, तो यू सी सपोज दिस इज माय स्पीयर, दिस इज माय स्पीयर. ओके, कोई भी हो सकता है, होलो कंडक्टिंग हो सकता है, होलो नॉन कंडक्टिंग हो सकता है और सॉलिड कंडक्टिंग भी हो सकता है, कोई भी तीनों में से कुछ भी ले जाओ, क्योंकि चार्ज रिसाइड्स ऑन द सरफेस. यू सी, सो चार्ज रिसाइड्स ऑन द सरफेस. सरफेस में चार्ज रहता है, अंदर नहीं. क्लियर? ओके, सो लेट द रेडियस ऑफ द स्फीयर बी कैपिटल R. Let the radius of the sphere be capital R, and we are interested to find out the electric field intensity at this point. Distance small r from the center of the sphere. Okay, let the point be P. So P is a point which is outside the surface. You see, P is a point outside the surface, and we are going to find out electric field intensity at this point. Clear? Okay, how to find out? So we have a wonderful tool with us to find out the electric field intensity. We are going to use that tool. Okay, हमारे पास एक ब्रह्मास्त्र है, पहले हम डिस्कशन कर चुके हैं. So सोचो कौन सा? What is our brahmastra? Gauss's law. So Gauss's law is a wonderful tool in the hands of you all students, we all teachers and all scientists to find out electric field intensity due to uniformly charged distributions. Okay. So applying, you see, now applying Gauss's law, we know it is integration over closed surface E dot ds that will be equal to 1 divided by epsilon naught times the total charge enclosed within the closed surface. So this is my law. The total flux, the total electric flux linked with a closed surface is equal to 1 divided by epsilon naught times the total charge enclosed within the closed surface, and that closed surface is nothing but our Gaussian surface. So we are interested to find out the electric field intensity at this point, which is outside the surface of the sphere chosen. Okay, so now I am going to draw a closed surface with radius small r. Okay, and this is my spherical Gaussian surface. This is my spherical Gaussian surface. This is my spherical Gaussian surface. Clear? So now we will consider a small area over here. And you know, area vector is represented by an arrow. In case of a closed surface, it is outward normal. It is represented by outward normal. So this is my ds vector. And the electric field is again radially outward. Electric field intensity is again radially outward. So you see the situation, theta will be equal to 0. The angle between your electric field intensity vector at this point and area vector make 0 angle. Clear to all of you? So come over here. Now we are going to open this. So integration over closed surface E ds cos theta. E ds cos theta. A dot b is equal to ab cos theta. Dot product. So E ds cos theta will be equal to 1 divided by epsilon naught times the total charge enclosed within the closed surface. Now you can see this is my Gaussian surface. This is my Gaussian surface, and the total charge inside this Gaussian surface is the charge on this sphere, which is Q. Let it be Q. Total charge on the surface of this sphere be Q. So this is my Q. This is Q. So Q in, you see Q in is equal to Q. The charge given to this sphere. Okay? चलो आगे बढ़ते हैं. So this implies E is a constant quantity. You see, R is constant everywhere. R is constant everywhere. Although the directions are different. Although the directions are different, but the magnitude is same. But here the E is the magnitude of electric field intensity, because E dot ds is equal to magnitude of E, magnitude of ds, and cosine of the angle between them. So this is the magnitude which is constant everywhere on this surface. So that's why, so E can be taken out of the integration. It can be taken out of the integration. So integration over the closed surface ds cosine of theta. If theta is equal to 0, then cos theta will be equal to 1. If theta is equal to 0, then cos theta will be equal to 1. So this becomes 1. Okay. So is equal to Q divided by epsilon naught. Q divided by epsilon naught. Now, what is the limit? You see, this is a sphere of radius of small r. So limit varies from 0 to 4 pi r square. 0 to 4 pi r square. Okay. So this implies E is the constant quantity, and integration of s, ds will be s, runs from 0 to 4 pi r square is equal to Q divided by epsilon naught. Clear? So this implies E multiplied by 4 pi r square. 4 pi r square will be equal to Q divided by epsilon naught. Clear? Okay. So E will be equal to, this E is nothing but our E out. E out. E outside. The electric field at this point P, which is outside the surface of the sphere chosen. Okay. So E out will be equal to this 4 pi r square will be taken that side. So that becomes 1 divided by 4 pi epsilon naught. Okay. Q divided by r square. So this is my final result. E outside will be equal to 1 divided by 4 pi epsilon 0, Q divided by r square. Let me see whether it is coming within the vicinity of the figure. Okay. Very clear. Thank you. Listen carefully. E outside will be equal to 1 divided by 4 pi epsilon 0, Q divided by r square. मेरे को बताओ, अगर मेरे पास एक पॉइंट चार्ज होता है इधर, मेरे पास अगर एक पॉइंट चार्ज होता, इसका चार्ज अगर Q होता, बताओ मेरे को, R डिस्टेंस में इतना जो R डिस्टेंस, यही R डिस्टेंस में अगर एक पॉइंट होता तो इधर इलेक्ट्रिक फील्ड इंटेंसिटी कितना होता बताओ मेरे को. पहले से हमको पता है, इट इज अगेन 1 डिवाइडेड बाय 4 पाई एप्सिलॉन नॉट Q डिवाइडेड बाय R स्क्वायर. You see, the expression matches. The expression match each other. तो इसमें से एक बहुत इंपॉर्टेंट कंक्लूजन हमको मिलता है. this extended body, this extended sphere, this charged sphere behaves like a point charge for an outside surface. For an outside point, this extended body, this charged sphere will behave like a point charge, as if the total charge of the body is concentrated at its center. Got my point? देखो, पॉइंट चार्ज का r डिस्टेंस में जितना इलेक्ट्रिक फील्ड इंटेंसिटी, एक्सटेंडेड बॉडी का जिसका रेडियस r है, इट्स नॉट ए पॉइंट चार्ज, इट्स एन एक्सटेंडेड चार्ज, इट्स ए चार्ज डिस्ट्रीब्यूशन, स्पेरिकल चार्ज डिस्ट्रीब्यूशन ऑफ चार्ज. ओके, तो इसके लिए भी आउटसाइड पॉइंट में r डिस्टेंस में इलेक्ट्रिक फील्ड इंटेंसिटी का वैल्यू उतना ही आता है जितना हमारा पॉइंट चार्ज के लिए आता है. सो इसमें से एक वंडरफुल कंक्लूजन हम ड्रॉ किए हैं कि दिस चार्ज्ड स्फीयर, दिस होलो कंडक्टिंग, होलो नॉन कंडक्टिंग एंड सॉलिड कंडक्टिंग चार्ज्ड स्फीयर्स will behave like a point charge, as if the total charge is concentrated at its center for an outside point. I am categorically telling, for an outside point they behave like a point charge. This is the conclusion we have drawn. Now note it down please. वीडियो को पॉज करो और नोट करो. सो इधर लिख के रखते हैं जो रिजल्ट हमको मिला. तो E outside, this is my E outside is equal to 1 divided by 4 pi epsilon naught Q divided by R square. Okay? Okay, now tell me, now case B. Okay, case 1 का B point. So on the surface, on the surface, on the surface. So you see, when we are dealing with outside the surface, here your small r is greater than your capital R. Capital R is the radius of the sphere and small r is the distance of the point where we are going to find out the electric field intensity. Where we are interested to find out the electric field intensity, this is my small r. So when we are dealing with the point which is outside the surface, your r is greater than r. But on the surface, when we are coming onto the surface, जब हम surface में आ जाएंगे, you see r will be equal to r. So surface में small r will be equal to capital R. Clear to all of you? So ये this r को छोटे करते जाओ, surface में आ जाओ. अगर ये P पॉइंट सरफेस में आ जाएगा, P पॉइंट अगर सरफेस में आ जाएगा तो स्मॉल r will be equal to capital R. तो now the expression is very easy. So E surface is equal to 1 divided by 4 pi epsilon naught. Okay, Q charge is same, but the small r can be replaced by capital R. So capital R का square. So this is the final result. Okay, बिना कैलकुलेशन में, बिना डेरिवेशन के हम कैलकुलेशन कर सकते हैं just by replacing capital R with small r. Okay, small r with capital R. Now write down over here. So the E surface is equal to 1 divided by 4 pi epsilon naught Q divided by capital R square. Okay, so note it down. Now the third situation देखो, C में inside the surface. Inside the surface. Inside the surface. So you see here small r is less than capital R. Small r is less than capital R. Okay. So ये सिचुएशन देखो थोड़ा बड़ा करके दिखाता हूं. Let this be my sphere. Charge is distributed on the surface. Okay, charge is distributed on the surface, and the radius of this sphere is capital R. Okay, and we are going to find out electric field intensity at a point P, which is inside the surface, where there is no charge. Charge is on the surface. Okay, inside there is no charge at all. So we are going to find out electric field intensity at this point, and this distance is small r, which is less than your radius of the sphere. Now we will adopt the same procedure. Okay, so let us draw the Gaussian surface. So this is my spherical Gaussian surface. So this is my spherical Gaussian surface. Okay. Now what I will do, again I will consider a small sphere. So it is represented by outward normal ds. If at all electric field intensity exists, it will be radially outward. If it at all it exists, we don't know whether it exists or not, but it must be radially outward. So again theta will be equal to 0. Now again we will apply Gauss's law. So using Gauss's law, which is the total electric flux linked with a closed surface E dot ds will be equal to 1 divided by epsilon naught times the total charge enclosed within the closed surface. This is the statement. Okay, chalo proceed karo. So now we are going to open this E ds cos 0 degree is equal to q in. मेरे को बताओ q in कितना होगा. q in, you see ये मेरा गॉसियन सरफेस है, इसके अंदर चार्ज कितना है? इसके अंदर चार्ज है नहीं, इसके अंदर चार्ज नहीं है, बिकॉज चार्ज resides on the surface. There is no charge within the spherical Gaussian surface. So q in will be equal to 0. You see q in will be equal to 0. So right side becomes 0 divided by epsilon naught. Q in will be equal to 0. Now E is a constant quantity, whatever it may be. You see E integration over closed surface, the same procedure, ds 0 to 4 pi r square will be equal to 0. So this implies E multiplied by, for directly I am writing 4 pi r square will be equal to 0. This implies E will be equal to 0 because 4 is not 0, pi is not 0, r is not 0. So E must be 0. The electric field inside. So very important conclusion, very important expression. The E inside, okay, due to this hollow conducting, hollow non-conducting and solid conducting, ये तीनों केस में inside the sphere the electric field will be 0. Okay, so E inside is equal to 0. E inside is equal to 0. क्लियर टू ऑल ऑफ यू? क्लियर टू ऑल ऑफ यू? और कोई डाउट है इसको फिर से बैक करो, इसको रिपीटेडली देखो, ओके, बार बार देखो, कंसेप्ट क्लियर हो जाएगा. ओके, सो वेरी इंटरेस्टिंग केसेस. नाउ वी आर गोइंग टू ड्रॉ ए ग्राफ. हाउ इलेक्ट्रिक फील्ड इंटेंसिटी वेरीज. हाउ इलेक्ट्रिक फील्ड इंटेंसिटी वेरीज when we proceed from center to the surface and towards the outside of the surface. Let me erase this portion also. Now you see, okay, now we are going to plot a graph. You see, okay, so charge resides on the surface, we know. Charge resides on the surface. So this is the center of the sphere. Let it be O, and this is my radius. This is the radius of the sphere. Okay, so little bit नीचे करते हैं. So this is R. Okay, along the x-axis we have taken R, and along y-axis we are taking electric field intensity. Okay, x-axis में R को लेते हैं, y-axis में electric field intensity को लेते हैं. चलो ग्राफ प्लॉट करते हैं. You see, now drop a perpendicular from this point. Okay, you see, this is the portion that is inside the surface, and here is the center. ये सेंटर है, स्फीयर का सेंटर है. सो ये पॉइंट, ये हमारा, इसको अगर O नाम देते हैं, ये हमारा सेंटर where R is equal to 0. R is equal to 0. Here you see, R, this is the surface. Here R is equal to R. And this is my inside. This is the, you can write over here. This is inside. From here to here, we are inside the surface. This is the inside portion. Okay. This is the center. This is the surface. This is inside. And from this what side? It is outside. Here your R is less than R. R is less than R, and here R is greater than R. Now we are going to plot the graph between R and E. See, you see, from the center up to the surface, it is 0. Now let me take this new color. You see, this 0, 0, 0. This is 0. This is 0. Okay. Now, when you are coming onto the surface, जब सरफेस में हम आ जाएंगे तो इमीडिएटली इसका वैल्यू बढ़ जाता है. ये you see. So here, this is your E surface is equal to 1 divided by 4 pi epsilon naught times 1 divided by 4 pi epsilon naught times Q divided by R square, capital R square. This is the value on the surface. And then it varies like this. E outside varies inversely as the square of the distance from the center. So this is the graph. So 0 at the center, up to surface, that means just within the surface. Up to the surface, it is 0. On the surface, it drastically increases to 1 divided by 4 pi epsilon naught q by capital R square, where R is the radius of the sphere. That means, and after that, outside the surface, it decreases in as if it is inversely proportional to the R square. So E outside will be equal to 1 divided by 4 pi epsilon naught q divided by R square. Okay. So as the distance increases, E decreases like this. Okay. डिस्टेंस 2 गुना हो जाएगा तो इलेक्ट्रिक फील्ड इंटेंसिटी 4 गुना घट जाएगा. डिस्टेंस अगर 3 गुना हो जाएगा तो इलेक्ट्रिक फील्ड इंटेंसिटी 9 गुना घट जाएगा. ओके, लाइक दैट इट डिक्रीजेस विथ R square. So this is the graph which explains everything about electric field intensity due to this hollow conducting, hollow non-conducting and solid conducting. Okay, it's an interesting graph. Please study this graph. Okay. Now you see, okay, what happens? क्लियर है? कुछ डाउट है क्या? कुछ डाउट है? अगर कुछ डाउट है, कुछ प्रॉब्लम है तो प्लीज मेंशन करो, कमेंट करो मेरे को, मैं डेफिनेटली आंसर करूंगा. और कुछ पॉइंट है क्या इसमें बोलने के लिए? इट्स वेरी क्लियर नाउ. ओके, सेंटर में 0 अप टू सरफेस इट इज 0. ओके, एट द सरफेस it drastically increases to 1 divided by 4 pi epsilon naught q by R square, and outside the surface it behaves like a point charge. For outside point, this whole extended charge of the sphere will behave like a point charge. Okay, and E out is inversely proportional to R square, and this surface is the surface of discontinuity. This surface is the surface of discontinuity. surface देखो, surface के बाहर ये डिक्रीज करता है, एंड सरफेस में मैक्सिमम. जब अंदर जाओगे तो E का वैल्यू ड्रास्टिकली बिकम्स 0. ओके, सो दैट्स व्हाई दिस सरफेस इज द सरफेस ऑफ डिसकंटिन्यूटी. ये हमको चाहिए. ओके, जब हम इलेक्ट्रिक फील्ड पोटेंशियल निकालेंगे, ये जो नेक्स्ट वीडियो में हम इलेक्ट्रिक फील्ड इंटेंसिटी निकालेंगे. सो इलेक्ट्रिक फील्ड पोटेंशियल हम निकालेंगे. जब पोटेंशियल निकालेंगे तो ये जो सरफेस ऑफ डिसकंटिन्यूटी का कंसेप्ट उधर यूज होगा. ओके, तो प्लीज कीप इन माइंड. सो थैंक यू ऑल. वीडियो को ज्यादा लंबा नहीं करते हैं. जो हमारा फोर्थ टाइप का स्फीयर है, द यूनिफॉर्मली डिस्ट्रीब्यूशन ऑफ चार्ज, फोर्थ कैटेगरी, सॉलिड नॉन कंडक्टिंग यूनिफॉर्मली डिस्ट्रीब्यूशन ऑफ चार्ज का जो फोर्थ केस है, हमारा केस 2 है, लेकिन फोर्थ टाइप का जो स्फीयर था हमारा, इसका इलेक्ट्रिक फील्ड इंटेंसिटी हम निकालेंगे नेक्स्ट वीडियो में, क्योंकि वीडियो लंबा नहीं करेंगे. थैंक यू ऑल, गुड बाय.